Come back. We now start on chapter 6, section 6.1, inverse functions. Let us recall some of the basic definitions first. So section 6.1 deals with some basic definitions. Okay, you probably have seen these definitions before. First definition, let X and Y be two sets. A relation R from X to Y is a subset of the set X cross Y. That's it. Relation is a subset of X cross Y. X first, Y next. We may view this relation R, so that colon is read from R from X to Y. We may view this relation as simply an association of elements from X to Y. For example, here is a picture. This is set X. This is set Y. All right. The first element of X is associated to three elements of Y. Second element of set X is associated to one element of Y. Third element, one element here. Fourth element, one element here. Fifth element, not at all, not associated at all. That's okay. So this is an example of a relation, an association from the first set to the other set. Okay, however you associate is okay. If you don't associate someone, that's okay also. Now what is a function? A function starts with two sets X and Y. A function f from X to Y is a relation from X to Y. So to begin with, function is a relation such that for each X in X, there exists a unique Y in Y, such that the pair XY is in F. Remember, a relation is a subset, so this makes sense. Now, this definition can be a bit abstract for a new student of mathematics. Here is the more familiar definition of a function. A function f from X to Y is an association from the set X to set Y, such that for each X in X, there exists a unique Y in Y, such that f associates Y to X. You denote this association by f of X equals Y. For example, here is a function. Every X, every element in set X is associated to somebody here. Okay? And a unique, so first element here has only one place to go. Remember in the previous case, the first element has three associations. That's not okay anymore. Every element on the left must have only one person on the right to be associated with. This person, this element is associated to Y5. This element is associated to Y1. This element associated to Y2. This element, so everyone must be associated to someone uniquely, right? So what is happening here? This element is associated to Y5, so is this element associated to Y5. But that's okay. The condition is that for each X, there is a unique Y. So for each X, you are allowed to go to only one element on the right. Different elements on the right can have other associations, more than one association. That's okay. But elements on the left must have one and only one association. So think of F as an airline. Okay? These are passengers, these are destinations. Two passengers can go to the same destination. That's okay. But one passenger cannot go to two different destinations. One passenger cannot go to here three different destinations. Every passenger must be able to go somewhere. This passenger is not being taken anywhere. So that's not a function. Every passenger must have one and only one destination. That's a function. It's okay for two different passengers to have the same destination as long as every passenger has one and only one destination to go to. That's a function. Okay. Now, in this particular figure, if we reverse all the arrows, we no longer obtain a function. Say if I reverse all the arrows, so y5 will end up in two different destinations. So it's no longer a function. Moreover, y3 has nowhere to go. So that also is a failure, right? For a function, every x should have a unique y, all right? Now, if I reverse it, this guy has two places to go, so that fails. This guy has nowhere to go, that also fails. So if I reverse all the arrows, we no longer obtain a function. Further, let us understand the notion of domain, codomain, and range of a function. So for this function, domain is the set of all those elements for which f is defined. Here, f is defined for every element, so the entirety of x is my domain. Y is my codomain. Okay, even things which are not hit, that's okay, that's codomain. Set y is the codomain of f. What is the range? Range of a function from here, x to y, is the set of all those elements from y for which there is an x. So here you are looking for those elements which are hit by x. So notice y3 is not touched by f, right? So y1, y2, y4, y5, that's the range. So domain is everybody, range is only those elements, set of those elements which are achieved by f. Okay. What is an injective function? Injective function, start with a function. Let x and v be two sets. A function f from x to y is said to be injective or one-to-one if whenever x1 is not equal to x2, for elements in x, we have fx1 is not equal to fx2. What does that mean? So remember, I'm thinking of the left hand side as my passengers. Two different passengers, that's what not equal means. If I have two passengers who are unequal, then their destinations also must be unequal. That is, two different passengers must go to two different destinations. So in the previous case, this was a function. I had two different passengers go to the same destination. Well, if I want to be an injective function, then that should not be allowed. In an injective function, two different passengers must land in two different destinations. Injective function is also called one-to-one function. Okay? Which brings us to surjective. Let xy be two functions. A function, so notice injective or surjective makes sense if they are functions first. So they have to be functions first. A function f from x to y is said to be surjective. Surjective is also called onto if for every y there exists an x. So notice here in the previous case, this particular y did not have anyone go to it. That's not okay. In a surjective function, every element must be hit. It's okay if two passengers go to one destination, but every destination must be hit. That is surjective. Okay. This is surjective, but notice it is no longer injective. This and this passenger go to the same destination. So it is not injective here, but it is surjective. So what happens in the surjective case, a range, that is all the destinations that are hit, is equal to all possible destinations. So range equals codomain. That's what is surjective. All right. So I hope the distinction is clear. In injective, two different passengers have to go to two different destinations. In surjective, every destination must be reached. For a general function, well, two different passengers may go to the same destination, that's okay. A certain destination was not hit, that's okay too. But what's required is every passenger goes to one and only one destination. Every passenger goes to one and only one destination. In a relation, even that constraint is not required. A passenger could go to more than one destination. Some passenger has nowhere to go. That's okay. Any association is called relation. When we require every passenger to go to one and only one destination, that becomes a function. When distinct passengers have to go to different destinations, that's an injective function. Surjective means when every destination is hit by some passenger or the other. Which brings us to bijective function. What is bijective? Bijective function means it is a function to begin with. It is both injective and surjective. So, f must be a function, that is, every passenger has some unique place to go to. Moreover, two different passengers will go to two different destinations, and every destination is hit. That's a bijective function. Okay? In a bijective function, if I reverse the arrows, I get a function again. That's an inverse function. All right? I will continue in my next video.